Let's continue with Chapter 4, Test Review Worksheet number 3. This is number 3 here. Table below shows the speed of a sprinter at the time intervals in seconds in the 200-meter race. Okay, so these are all going to be using Riemann sums or trapezoid approximation. So part A, estimate the definite integral of v of t from 0 to 20 using the following methods. 6 trapezoids using the intervals provided. So we see if we try to break this into 6 intervals, we see there's one interval between 0 and 2, second between 2 and 5, third between t values 5 and 8, fourth between 8 and 11, fifth between 11 and 17, and then finally sixth between 17 and 20. So we have these 6 intervals that we can find areas for. Okay, so just as a reminder, the area for trapezoid is width divided by 2 times h sub 1 plus h sub 2. Okay. Now we could use just one formula for to find the area, but notice that we have different widths in each of these intervals, so we have to find the areas of these trapezoids separately. So for the first trapezoid, the width between 0 and 2 is simply going to be 2, where we simply just subtract these values. So 2 minus 0 is 2. So plug into our formula, width over 2, 2 over 2 times h sub 1 plus h sub 2. So the two velocity values, which will represent the heights, the y values of this graph, is simply 5 plus 6.5. So this is the area of my first trapezoid. My second trapezoid is between the interval of 2 and 5. So 5 minus 2 is 3. That's my width. So 3 divided by 2 times my two y values added together. So 6.5 plus 7. Okay. Third interval is between 5 and 8. Again, this will give me a width of 3. So 3 divided by 2, and then add the appropriate y values, 7 plus 8.5. Okay, we go down the line here. The fourth, 11 minus 8 is 3. So again, it just so happens for these past 3, we've had the same width. 3 over 2, and we add the appropriate heights, 8.5 plus 9. Okay. Fifth trapezoid, between 11 and 17, this will be different. 17 minus 11, this is a width of 6. So plug into our formula, width is 6, 6 over 2 times 9 plus 8. And finally, between 17 and 20, width of 3, so 3 over 2 times 8 plus 7.5. Okay. This is a calculator portion, so we can simply plug all this in your calculator, add up all the areas of these trapezoids, and we're going to get 155.5 meters. Now, the accumulation of all these velocities will give us the approximated area. Now, this is a 200-meter race. Obviously, this is going to be an under approximation of the actual area. Okay, 155.5 meters. All right, for part 2, now we want to approximate the area under this curve using 3 left-handed rectangles. So here I just separated, divided this up into 3 subintervals, okay, according to the values given to us. And for this first interval, I'm only going to look at the endpoints for my first rectangle. So 5 minus 0 is simply going to be 5. My width is 5. I'm always going to ignore anything that's in between. Okay. So 5 minus 0 is 5. Left-handed rectangles means that I'm going to be choosing the left endpoint, the left height in this in these subintervals here. So v of 0 would be the height for my first rectangle. So my first rectangle has a width of 5, and the height, I'm going to be using v of 0 to determine the height, because I'm using they're telling us to use 3 left-handed rectangles. For my second interval, I'm looking at 5 and 11, so 11 minus 5, this is a width of 6, so my second rectangle has a width of 6. And again, I'm going to choose the left endpoint. So for my second interval, my left endpoint is v of 5, which is a value of 7. And finally, my third interval is between 11 and 20, so 20 minus 11 is 9, so that's my width. And I'm going to choose the height based off of this left interval, so v of 11 is equal to 9. So multiply this out, 25 plus 42 plus 81 gives 148 meters. Okay, part 3, 3 right-handed rectangles. So the interval is going to be the same. Okay, still 3 subintervals, so we're still going to use the same width as before, so 5, 6, and 9. Now we're going to be choosing the right upper right corner of each rectangle. So for the first rectangle here, I'm going to choose 7, or v of 5. For the second interval, I'm going to choose v of 11, which will have a velocity of 9. And then third interval, the right upper right corner, which is v of 20, which is 7.5. So plug those values in, multiply those out, and our approximation will be 156.5 meters. Okay, part 4, now we're using 3 middle rectangles, so we want to choose the middle value of each interval. So the middle value of each interval for the first rectangle would be v of 2, which I'm going to be choosing 6.5 as the height. Notice we're still using 3 subintervals to estimate the same area, so the width is still going to be the same for part 2, 3, and 4. For the second interval, I'll use 8.5 as the height, and for the third subinterval, I'll use v of 17, which has a velocity of 8. So we simply plug those values in. Width times height, width times height, width times height. We add up the areas of all these rectangles, and we're going to get 155.5 meters. All right, part B, find the average velocity on the interval 0 to 20 using estimation from our 6 trapezoids, so from part 1. Okay, so to recall, average velocity, average value theorem is 1 over b minus a times the definite integral from a to b of v of t dt. A value is 0, b value is 20, so we plug all those values in. So 1 over 20 times the definite integral from v of t from 0 to 20. We're only doing the estimation from part A, so we found from part A that the definite integral of v of t from 0 to 20 is estimated to be 155.5. So replace this notation with 155.5. So average velocity is simply the area divided by the width will give us 7.775. Average velocity, so we have to include the appropriate value here. Meters per second is the unit of measurement.